Dear students, let us try to solve this question from GATE Mechanical 2023, which was asked on thermal stress. Let us read the question first. Cylindrical bars P and Q have identical lengths and radii, but are composed of different linear elastic materials. The Young's modulus and coefficient of thermal expansion of Q are twice the corresponding values of P. Now, whenever we are reading a question, we should always try to write down the values that are given, and it always helps. So what is given is that length of P is equal to length of Q. Radius are equal means area of P is equal to area of Q. But the materials are different means if I'm assuming the Young's modulus of P is equal to E, Young's modulus of Q is given twice of P, that is, it is going to be twice of E. And same is the case with coefficient of thermal expansion. If I assume that coefficient of thermal expansion of P as alpha, then the corresponding value for Q will be twice of alpha. This is what is given in the equation, right? Assume the bars to be perfectly bonded at the interface and their weights to be negligible. The bars are held between rigid supports as shown in the figure, and the temperature is raised by delta T. So we increase the temperature of the entire system. Assume the stress in each bar is homogeneous and uniaxial. Denote the magnitudes of P and Q are sigma 1 and sigma 2. So the stress in P is sigma 1, stress in Q is sigma 2. And we have four different options. Which of the following statements is are correct? So whenever equation is are comes up in the option, right, you must understand this is going to be MSQ, that is multiple select question, means multiple answers can be correct. So let us try to figure this question, how to solve it. Now, going deep into it, right, when we raise the temperature, both the tendency of both P and Q will be to increase. The length of both P and Q will want to increase. So as a result, what will happen? It will apply pressure on both the walls. And the walls will generate reaction force because of this. Right? The walls will generate reaction force because of this. Let me say the reaction forces are R1 and R2. Now, because the entire system has to be in equilibrium, I can say that summation of forces should be equal to 0. External forces, summation of all external forces on the system should be equal to 0. What it means is that R1 minus R2 should be is equal to 0. And from here, we can conclude that R1 is equal to R2 is equal to, let me say, R. Both of the values R1 and R2 are going to be same, equal. Now, if you want to calculate what is the stress, sigma 1. Now, sigma 1 is nothing else but the force which is being applied on 1. That is basically the force is nothing else but the R1, right, which is equal to R. So, the force divided by its area. And what will be the stress on 2? It is again going to be the force on Q, right? Sigma 2. Force on Q is nothing else but R, and its area is also A. So you can clearly see that both sigma 1 and sigma 2 are equal. So this makes our last option, option D, correct. Now, in the other options, A and B, what is being asked is the interface between P and Q. Is it after heating, does it move towards left or does it move towards right? Okay. Let me denote a point A at the interface. So this is the interface. So I need to find out the point A after heating, does it move towards left, right? Or does it move towards right? So this is what I want to find out. To find that out, we simply need to find out what is the change in length of P and Q. Now let us try to understand what is the change in length of P, delta LP. Now the change in length of P will be dependent on two things. First of all, the temperature is increasing. Now if the temperature increases, the length of the rod P will tend to increase. How much? Alpha delta T L. So this is the change in length of P because of increase in temperature. But wait, there is also a reaction force, and which is compressive in nature. And because of this reaction force, what will happen? The tendency of the length will be to decrease. So I will say minus the force into length divided by area into E. This is the change in length, decrease in length. Why minus sign? Because it is compressive, it is going to decrease. So I'm writing it as minus RL by AE. So this is the total change in length of P. Similarly, let us try to determine what is the total change in length of Q. So the total change in length of Q is the change in length of Q because of temperature increase. Now, mind you, the alpha of 2 of P is twice that of Q. You can see alpha of PQ will be twice of alpha. So twice of alpha, change in temperature is same for both, delta T, and length is same for both. So this is the increase in length because of temperature increase minus RL because of the compressive force. Again, the length will tend to decrease, divided by area is same, but the Young's modulus is twice of E for Q. So these are the two values of change in length of P and Q. Now, if you compare both of them, you can clearly see that the increase in length is more for Q. Decreasing length, because the 2 comes in the denominator, the decreasing length because of the compressive force is less for Q. So overall, if you compare this two equation, you can clearly make out that the change in length of Q will be greater than the change in length of P. And if that is the case, I can clearly say that the point A is going to move towards left because the length of Q will increase. In fact, you should also be able to understand that total change in length will be 0. So if this is positive, this is basically going to be negative. Right? If you calculate, if the values are given and if you find out, then this is going to be negative. So now what it says is that this interface is going to move towards left after heating. So the correct answer is going to be A. So here two answers are correct, two options are correct. Correct answers are A and D. I hope you understood it. If you have any doubt, please make sure you comment it and I will be very, very happy to solve your doubt. Thank you.